Hi, in this video we are going to explore the concept of chemical bonding, why atoms form bond, how these bonds are formed, the energy change involved in bond formation, and key properties like bond length and bond energy. Everything we see, touch or use, from air and water to metals and living cells, is made up of atoms which are connected by chemical bonds. This is invisible force or glue that connect the atom together and form molecules, compound or matter. For example, hydrogen and oxygen are atoms. Two hydrogen and one oxygen atoms combine together through chemical bond and form water molecules. This chemical bond is the force which connect the atom together and form molecules or compounds. No, this is a question why atoms form chemical bond. Everything in the universe wants to be stabilized, and atoms are not stable. To gain the stability, they form chemical bonds. For example, again, hydrogen and oxygen atoms are not stable. To gain the stability, they combine together and form water molecules. In the molecule, these atoms are stable. Similarly, other different atoms combine together through chemical bond and form different compound molecules or matter in which they are stable. Now, this is another question. How through chemical bonding atoms gain stability? Atoms are chemically plus magnetically reactive, have higher energy and not have symmetry. And anything which have the higher energy is reactive and less stable. And during bond formation, these atoms release energy and gain stability. Atoms are reactive, have high energy and not have symmetry. This is all because they do not have their filled outermost shell. For example, hydrogen atom. This have electronic configuration 1s1. This has one electron in subshell S or in first shell. There can be maximum 2 electrons. So this has the deficiency of 1 electron. And oxygen atom has electronic configuration 1s2, 2s2 and 2p4. Here p subshell have maximum 6 electrons, so this have the deficiency of 2 electrons. These atoms combine by chemical bond and form molecule. In molecule, these atoms have maximum electron in their shell or subshells. As oxygen atom gain maximum 8 electron in the second shell and hydrogen gain 2 electron in the first shell. This is the octet and duplet rule. As atom have gained maximum 8 and 2 electron and electronic configuration like noble gases. Behave stable or inert or chemically unreactive. Here, hydrogen atom have maximum 2 electron in subshell S which are paired and oxygen atom have maximum 6 electron in p subshell which are also paired. These paired electrons have the spin equal but opposite which cancel the effect of each other. And these atom or molecule are called diamagnetic which behave magnetically unreactive. So, in this way after chemical bonding atom gains stability and symmetry. Let us now we discuss another example. For example, oxygen molecule. Here two oxygen atoms are connected through double bond. And each oxygen atom have their outermost shell filled or complete and have electronic configuration like inert or noble gases. So these atoms chemically behave inert or stable. But although this molecule have even or 16 electron but behave magnetically reactive are known as paramagnetic. This is because oxygen atom have unpaired electron which is according to molecular orbital theory and due to nature of molecular orbital filling. In magnesium chloride, after chemical bonding, magnesium fill their outermost shell complete and chlorine also fill their outermost shell complete. Here magnesium gave 2 electrons and each chlorine atom gain 1 electron. In this way they gain the stability and fill their outermost shell. So in this way we can say that after losing, gaining or shear electron, atom gain the electronic configuration like noble gases and complete their outermost shell and become stable. Here in colloid the subshell is completed but the third shell is not completed. As d orbital is empty, but this do not take part in chemical reaction for all main group elements. So we can say that this is chemically filled but quantum mechanically is not filled. Let us now we discuss the energetics of bond formation or process of bond formation. Let's suppose we have two hydrogen atoms which are at infinite distance and have no interaction. And these atoms have potential energy 0 which is due to interaction and position of these atoms. And potential energy is equal to work which we can calculate from Coulomb's law. Here the product of force and distance is equal to work done or potential energy. At infinite distance there is no interaction between these two particles, as r distance is infinite. So the potential energy of these two particles at infinite distance is 0. And when these particles come close together, their repulsive as well as attractive forces operate. Repulsive forces operate due to similar charge, for example between electrons or protons. And attractive forces are due to opposite charge like electrons or protons. As we bring these particles close together, there is a point at the distance of 75 picometer where attractive forces dominate over repulsive forces. At this point, these particles have minimum energy and maximum stability and form chemical bond. Here, through this equation, we can calculate the potential energy when the attractive forces are more than repulsive forces. And as we know that attractive forces operate between opposite charges. Here, when the charges are opposite, the result is negative and we can say that the potential energy is negative. It means that when these particles come close together till distance 75 picometer, they release energy and gain stability. Here, potential energy is negative which means that this is less than 0. These particles release energy 436 kJ per mole when they move from infinite distance to at distance 75 picometer, which is bond length or bond distance. And when we bring these particles further close together, like charges which are proton or electrons repel each other and in this way repulsive forces dominate and system become unstable and energy increase. Now we can calculate potential energy when repulsive forces are dominant, which are due to similar charges. Here, when the charges are similar, the result is positive. It means that we work on the system and we work to bring the atoms further come close together. And as the energy increases, system become unstable. We can summarize at the distance of 75 picometer, which is the bond length. At this distance, attractive forces are dominant over repulsive forces and system becomes stable. As system release energy. And we can also say that when atoms join together through chemical bonding, they release energy and in this way they gain stability. As hydrogen atoms combine together and form chemical bond at the distance of 75 picometer, and in this way they release energy which is 436 kilojoule per mole. Now this bond length and bond energy decide the strength of chemical bonds. When the bond length is higher, the bond energy will be lower. There are three main factors which decide the bond length and bond energy, in which one is the difference of electronegativity. When the electronegativity difference between atoms is higher, the bond length will be lower and bond energy will be higher. And as the electronegativity difference increases between atoms, this increases the unit character. And as the unit character increases, the bond energy or stability of bond increase and bond length decrease. For example, hydrogen fluoride have the strongest bond among halogen acid. This is because fluorine is most electronegative atom attract the bond pair electrons strongly. In this way, bond distance decrease and the bond energy increase or the bonds become stronger. And when we discuss the hadroids of other halogen, as we move from top to bottom, the electronegativity difference decrease. And as the electronegativity difference between atoms decrease, the ionic character also decrease and covalent character increase. This moves toward less stability and more reactivity. So we can say or we can summarize bond length increase or bond energy decrease as the electronegativity difference decrease. And bond move from ionic to covalent. The other factor is the sizes of atom. This is very clear as the sizes of atom increase, the electronic load or the shell increase. So in this way, the bond length increase and the bond energy decrease. For example, in hydrogen colloid molecules, hydrogen is very small and chlorine is bigger one. The bond distance between them is 127 picometer. In chlorine molecule, the both atoms are bigger and the bond distance is higher, which is 199 picometer. In hydrogen molecule, the both atoms are smaller, so the bond length is lower, which is 75 picometer. We can say this is stronger bond. And in groups, when we move from top to bottom, the sizes of atom increase, so the bond length increase and the bond energy decrease. In periods, when we move from left to right, the sizes of atom decrease and so bond length decrease and bond energy increase. For example, the bond length between silicon atom is greater as compared to between carbon atoms. Both these atoms belong to same group, but the sizes of silicon are higher, so the bond length is greater and the bond energy is lower. And the bond length is greater between phosphorus atom as compared to nitrogen atoms. Both these atoms belong to same group, but the sizes of phosphorus is higher, so the bond length is higher and the bond energy is lower. And the third factor is bond order. When the number of bonds increase, the bond length decrease or bond energy increase. For example, when carbon atoms are connected through single, double and triple bond, their bond length begin to decrease and bond energy increase. As one carbon atom are connected through single bond, they have bond length 154 picometer and have 100 double 3 and 120 picometer when they are connected through double or triple bonds. In triple bond, there is one sigma and two pi bonds. And triple bond is not 3 times stronger than single bond. This is because sigma bond is stronger than pi bond. In case of benzene, the distance between carbon-carbon atom is 139 picometer. This is because of resonance. The bond distance is being considered between single and double bond. Thanks for watching and please comment if you have any question.